Alright, so now we're going to get away from SOHCAHTOA and learn some new definitions for our 6 trig functions. So the reason why is that our previous trig function definitions were restricted to only being able to take the sine, cosine, tangent of angles in between 0 and 90. Right, these new definitions will allow us to take the sine, cosine, tangent, cosecant, secant, cotangent of any angle, any real number angle, either in degrees or radians, doesn't matter. Alright, so let theta be an angle in standard position where xy is a point on the terminal side and r is the distance that that point is from the origin. Then we're going to define sine as y over r, cosine as x over r, tangent as y over x, and then since cosecant is the reciprocal of sine, it's going to be r over y, secant r over x, and cotangent x over y, because they're also reciprocals. Now, let's think about why this makes sense. So, no matter where you put this terminal side, alright, for this picture it's in quadrant 2, alright, you can always draw a line perpendicular to the x-axis, alright, and then that creates this right here as our reference angle. And that's why we study reference angles, because that's what we're going to use for reference to figure out what the sine or cosine of tangent of this angle would be. Alright, now if you were starting at this point right here, and you were trying to get to this point, xy, you would move to the left certain units, and then up certain units. So you move to the left x units, and up y units. Alright, now notice that x and y could be negative, because they're not, I didn't say they were the length of sides. I didn't say this side was x units length long. I said this is the x coordinate, that's the y coordinate. But we're going to use those coordinates sort of like as lengths, all right? And r is the distance that this point is from the origin. So we have a right triangle here, and r is like the hypotenuse, all right? And no matter where you put this angle, you can always find a point on the terminal side, x and y, and then the distance is r, all right? So y over r is actually just sort of like a synonym for opposite over adjacent, alright? Because if we look at this angle, this reference angle, alright, that's the opposite leg, alright, and that's the hypotenuse. Or I should have said, yeah, it's a synonym for opposite over hypotenuse. I misspoke, I apologize. Alright, so this is like the same thing as saying O over H, SOHCAHTOA, alright? This would be the adjacent leg here. So cosine of theta would be x over r, which is similar to A over H. Alright, and then y over x is opposite over adjacent. Alright, and then these here just the reciprocals. So h over o, h over a over o. Alright, so anytime you're dealing with secant, cosecant, cotangent, it's probably easier just to flip it, find the reciprocal, and then write it in terms of sine, cosine, or tangent. Alright, so those are the definitions that we're going to use going forward. We're going to use y over r, x over r, and so on and so forth. And you'll see it allows us to do a whole lot more. Okay, so I'll show you some better tips and tricks for doing these next 2 problems, but for now we're just going to apply the definition that we just learned. Alright, and that is that the cosine of theta is equal to x over r, where x is the x-coordinate of a point in your terminal side, and r is the distance that that point is from the origin. So for 120, I'm going to draw a 120 degree angle here. Alright, so that's the initial side. Alright, and then, oops, what happened? Let's come back to that. There we go. This would be the terminal side, okay? And the reference angle would be 60 degrees, okay? And I need to give myself a little more room here, so we're going to go 60 degrees, okay? Now, I need to find a point on my terminal side, so I'll just place a point right here, okay? Now, there are an infinite amount of points I could place here. It could really be any point, okay? So how do I know which point? It doesn't matter, but it has to be a point on that terminal side. So what I'm going to use, I'm going to draw this line, and I'm going to use my knowledge of special right triangles, okay? So to make my life easier, I'm going to call this length right here 1, because it's the side across from 30 degrees, okay? That means the side across from 60 is going to be root 3, because that's always the ratio between the short leg to the long leg in a 30, 60, 90 triangle. It's going to be 1 to root 3. Okay, then do the Pythagorean theorem or use special right triangles, and you get 2. Okay, now those are lengths, but if I was finding a point here, that would actually be -1, comma root 3, because now I'm moving to the left and then up. So from the origin, I'm moving to the left 1 units and then up root 3 units. So that gives me this point, -1, comma root 3. Okay. Now I'm going to find the cosine of 120 by doing x over r. x is -1, r is 1/2. So our answer is going to be -1/2. Okay, let's try that again with the tangent of 315. Okay, now if you ever forget the definitions like x, r, y over r, x over r, blah blah blah, I suggest you draw an angle in quadrant 1. Alright, this being the reference angle. Okay, this would be the opposite leg of the reference angle, this would be the adjacent leg, this would be the hypotenuse. Okay, so if this is our point on our terminal side, x, y, and this is r, okay, the adjacent leg is kind of analogous to x because you move to the right x, then you move up y, so that's like our opposite leg. So if I need to know what the definition of tangent was, since I know it's TOA, O over A, I'm going to use y over x. Okay, so now I have a 45-degree reference angle here, and it's that's all I really know because this is 315 degrees. So now I have to find a point on my terminal side. So let's just put a point here, and to make our lives easier, let's just say, right, that's going to be 45 because that's 90 degrees. Let's just say that that's 1 and that's 1 length. So then if I do the Pythagorean theorem, I get that's root 2. So now if I'm looking at this point, I'm moving to the right 1 and then down 1. So the point would be 1 comma -1, alright, x and y. Alright, and this would be r right here. So if I was doing the tangent of 315, you get x over r, 1 over root 2. That's, sorry, x over y, what am I talking about? My bad. X over y is 1 over -1, so the tangent of 315 is going to simplify to -1. Alright, we'll learn other ways to do this, but for now it's good to really use the definition. I want you to try it this way for this section.